Right, I have a new tool set up to show you today, a tailstock setup to enable screw tapping without the screw tap spinning in the tailstock chuck. And that's one of the problems you have with lathe work. When you use the larger taps, particularly in steel, you can try and tighten these keyless chucks up, or even the Jacobs chucks up, do them as tight as you can, but when the tap goes into the work, it won't be long before they actually spin in the chuck. And I have this very large Jacobs style chuck with a key, which is marginally better than the keyless type. I use this for medium-sized taps on the Chinese mini lathe and even on the Myford, but it still doesn't prevent the taps from spinning when using the larger taps or tapping in steel. And you can get dedicated screw tapping chucks for lathes and CNC machines. They're very rare to find and very expensive, but I'll show you today a chuck that you can actually buy from Banggood very cheaply, which will enable to do screw tapping with larger screw taps and eliminate all the spinning, so that you're able to use the spindle handle at the back of the lathe or even the motor to do machine tapping. So for those that are new to machining, you can do this chuck up as tight as you like, and when you take it into the component, you'll find that it'll go so far. I have screwed this one down a bit already, but at some point the actual tap will spin in that chuck and you won't be able to go any further. And very often with the bigger taps, you'll only just get a couple of threads before they actually start spinning. And sometimes with the force of the tapping, you'll even find the MT2 taper will actually slip in the sleeve. So what I did, I got this self-centering 4-jaw chuck from Banggood. It's 80mm in diameter, so it's not too heavy. It's excellent quality, well finished. It has an oiler in the front there for oiling the scroll. And like with the self-centering 3-jaw chucks, it comes with 2 sets of jaws. One set for the inside or smaller diameter work, and the other set for the larger diameter work. It has a nicely finished key and 3 6mm Allen bolts for securing the chuck to a back plate. Now the jaws are machined to a very close tolerance. There's no side to side movement, yet the chuck operates lovely and smooth over the full length of the travel of the jaws. And these self-centering 4-jaw chucks only have 2 key positions, and like with the 3-jaw self-centering chuck, you're only meant to use one of them all the time, and the one they intend you to use is normally marked with a 0. But if it isn't marked, I normally use the one that's adjacent to the oiler port and stamp that with a 0 myself. So if you're doing this setup, it's important to get a self-centering 4-jaw chuck and not the independent 4-jaw chuck. Now all the jaws are clearly marked up with their numbers, and the numbers 1 to 4. The chuck is stamped on the inside here with 1 to 4, but I found those numbers a bit faint. So what I do is carefully look at it with a magnifying glass, and so I don't make any mistake, I mark with a marker pen the actual number for the slot, and then I stamp up 1 to 4. I use 2.5mm stamps, and they're not too big, and it looks nice and neat on the front of the chuck. So to load the jaws up, get the scroll in the correct position for number 1 and put that jaw in. You can put all the other jaws in at the same time, and as long as you push all the jaws in and hold them while turning the chuck key, the scroll will pick up the jaws and they'll all go in their correct position. And I've tested this chuck on my lathe already, and there's very little run out. And that's another thing, these 4-jaw chucks are very handy besides being a good screw tapping chuck. You may have seen my other videos where I hold a 4-jaw chuck in a 3-jaw for doing very quick 4-jaw work. So next I got a 2-pound scales weight cast iron, and I turned up a back plate. First turned the register, and that one's a nice fit. Now on this chuck the screw holes are at the back. Some chucks the screw holes go right the way through, and it makes them easy to actually just put onto the register of the back plate, and you can use a transfer punch through to mark up the back plate and get the holes in the correct positions. But like I say, this one has screw holes at the back, but there's easy methods to actually transfer the position of the holes to the actual back plate. And the easy method that I use, I get some 6mm stainless steel grub screws and screw them into the actual thread right the way up until there's about 20 or 30 thou protruding, and this edge is quite sharp. You must get them all equal and in far enough so that the actual chuck will slip over the register, and then you can put a bit of glue on these edges of the actual grub screws, or you can actually sharpen them a little bit on that edge on the lathe before you do this. Put them on the register and then put it on a block of wood and give the chuck with the jaws in position like this and tightened up a sharp tap with a copper mallet like that, and you'll see the actual positions of those holes that you need to drill. So you've got a nice little circle there. You can center punch the center of that one and put it on the bench drill or the mill and drill those out. So if you use that method, you want to get it right first time, otherwise you'll have to clean the marks off and have another go at it. I use this marking glue here, which is very good, and this method works well with the chucks with the 6mm thread. If you have a chuck with a 8mm thread, what I do with those is I normally turn a point on the end of the grub screw and put it in backwards to the same sort of depth, and do the same thing, and you'll get a nice center punch dot. So next I bored through to a certain depth, about 100th thou from this face here, to accept one of these soft machinable 2MT arbors. These have a 3/8 thread in the back for the drawbar. And before I fitted the arbor, I drilled and tapped 6mm threads right the way through in 3 equal spaces between the holes on the front here, so that's nice and neat. I then put the soft arbor into the back plate with Loctite 638, put it on the bench drill and drilled down through with the core diameter again, so that it goes about 5mm into the head of the soft arbor diameter. I then put 6mm grub screw down so that the point goes into that hole on the arbor, and another grub screw behind it, and locked that up, and that's absolutely solid and runs dead true. So now the back plate's screwed tightly on the back of the chuck, and I use a 3/8 threaded piece of studding, screw that one down as far as it goes, and that will act as the drawbar. So now the drawbar thread goes down through the tailstock. I've cleaned the MT2 taper and I position the 0 key at the top. I've made a brass bush up which is a loose fit over the studding, and that one fits nicely in the bore of the tailstock quill, and then the 3/8 nut goes on the back there. Tighten that one up, and that will draw the MT2 taper into the tailstock and lock that one up. So when you're using this chuck, it's best to have the tailstock wound back so that the chuck is very near the actual tailstock, and that's because if you wind it out, it has a tendency to tip before it's actually locked up. But when you're using a chuck like this for threading, you don't actually wind the chuck out anyway. So it's a great size chuck to use for this tapping method, and there's plenty of clearance on the underside diameter between the cross slide. And for anyone that wants to use this size 80mm self-centering chuck on their lathes, and they have a lighter weight tailstock than the Myford ML7, at the end of the video I'll show you a counterbalance method that you can use to eliminate that tipping tendency. So the main reason that this type of self-centering 4-jaw chuck is excellent for tapping is obvious. The jaws will clamp on the square head of the tap on the flats, and when it goes in the chuck and it's tightened up, it's rock solid and there's no chance that it can spin. And now I'm going to do something on this Myford ML7 that I've never been able to do before, and that's to machine tap the other half of this thread using the motor. I've done it on brass and aluminium, but never on steel, and never with this size of thread. So I'm going to use the slowest back gear speed, which is about 50 RPM. And it went through that perfectly. And now I'll carefully reverse the motor and check that I'm not going to unscrew the chuck as I go back. And it did that perfectly. And there we have it, my first machine tapped thread on steel on this lathe. And this is a lock nut for a rear tool post that I'm making, and I hope to show that in a video at a later date. And obviously you can use the handle on the spindle mandrel at the back of the lathe if you have one. This one's been half tapped through already, and I usually do it like this, go forward a few and then back. And then just tap right the way through. And it takes quite a bit of force on a tap this size, so I'm very pleased that I can actually do it with the back gear. I think it's quite good to actually start the thread off with the handle and then just finish off in the back gear if you want. And another great thing about this chuck is that you can actually use it for ordinary drilling or reaming or whatever, so you're not just limited to it being a tapping chuck. And just before I go, I'd just like to show the counterbalance method if you have a lighter tail stock and still want to use this sort of size chuck. It's got the same bush in there, a longer threaded studding for the drawbar. I've made this brass adapter up here and have 3 of the weights from the weights you saw on the bench earlier. I've got a clip that just pushes around that one just to hold them together. A piece of brass pipe goes down there, and then I put the weights on the back, and the nut is screwed down onto that adapter to draw the taper into the tailstock, and that eliminates any tipping tendency. Plus the standoff here allows you to actually turn the hand wheel still. And another thing, on the Myford lathe, the headstock spindle has an MT2 taper, so you can actually use this setup in the spindle whenever you need a self-centering four-jaw chuck actually held in with a drawbar. So it's an excellent piece of equipment and well worth having.